Hi everyone, welcome to AgentStax. In today's video, we are going to cover one of the most important concepts in LangChain, which is memory. So without memory, an AI behaves like someone with short-term amnesia. Every new message feels like first time you are talking to it. But by the end of this video, you will understand how memory works. You will understand how different memory types, like in LangChain, we can use each one and which memory is the best for the real world AI applications. So without wasting any time, let's dive. So before we begin, if you are new to the channel, make sure that you check out the AI engineering playlist. We have covered LangChain basics and models, prompts, chains. Every video is designed to build one new previous one, not just theory. So consider subscribing Agent Stacks. My goal is to make this one of the most complete free AI engineering resource on YouTube. So let's now get started. So what is basically memory? So imagine you are chatting with a chat GPT and you say that, "Hi, my name is Joe." Then you ask, "What's my name?" So it correctly replies that, "Yeah, your name is Joe." But imagine if every single message started a completely new conversation. So you introduce yourself, then in the very next message, the AI says, "Sorry, I don't know your name." So that would be really frustrating. So that's the reason ChatGPT feels like a conversation. Because it remembers your previous message. So that concept exactly is called as memory. And in LangChain, memory allows your application to maintain a context across multiple interactions. So here you can see that I have mentioned in such a way that memory is something which allows your AI application to remember the information from the previous interactions and use that context in the future conversations. So we need memory because we need to maintain conversation histories. We need to enable multi-turn conversation and improve the user experience. So this is what basically LangChain memory is all about. So now comes what is the problem with memory? Without memory. So without memory, the user will feel like there is no context involved, there is no understanding to the AI, and you have to mention it again and again that I am the person, this is what I need, this is what I have. So here you can see that if the AI is forgetting the previous message, so it really becomes a frustration for the person who is working on it or who is using the AI, because without context, without personalization, without a conversational experience, the user may not be able to interact with the AI properly. So now how the memory solves this problem? So basically, there is a system where we used to interact with the AI. So once we give any input, so the memory stores the conversation. It will ask like if you mention your name, so that information is stored in the memory. So that memory exactly is what then in future, whatever you ask, based on your given information, the AI will fine tune your answer and provide you the right answer. So here you can see the workflow that when the user will give the input, it stores to the memory. And then when the prompt is asked, that information is passed to the LLM. And based on that, you will get the final response. So now comes the important part where we will discuss about the types of memory. So we have certain types of memory. You can see there one is conversation buffer memory. We have conversation summary memory. We have vector store memory, and we have an entity memory. So it's not limited till here. We have a lot of memory types. You can just refer LangChain documentation where you will be having a separate section on memory. So there you can understand completely like, okay, these are the types of memory. And in the upcoming time, we will be also I will be showing a demo like how we can use this different memory with just changing one single line of code. So let's understand about this is just a basic understanding what I am trying to give here. We will be going more detail in the upcoming slides. So first is a conversation buffer memory. So it stores the complete conversation where it stores the previous complete conversation. It stores the complete conversation. So like whatever you are giving as input, it's storing everything. Then we have a conversation buffer memory, which also comes under the conversation buffer window memory. So window memory and buffer memory are almost relevant to each other, but in window buffer memory, we are just assigning some k value. So k value basically like you will assign like you have to store the last k information. So this is what conversation buffer memory is all about. Then we have a conversation summary memory where we actually summarize the previous version of the conversation. So, for example, you have mentioned somewhere like um, you have mentioned a paragraph maybe to the AI, and then you have again given a paragraph. So it will not pass the entire context. It will pass the conversation. It will pass the summary of the entire context. So this is what conversation memory is all about. Then we have a vector store memory. So this will be something a more advanced thing which we'll be covering in upcoming videos when we'll be discussing about RAG. So it's basically like it retrieves relevant memories using the form of embeddings. Then we have entity memory where the memory will exactly take whatever the important informations you are sharing. For example, if you're sharing your name, you are sharing your company name, you are sharing some place, or you may be sharing some financial information. So these all details which are important maybe for the AI to evaluate or understand or give something which may be relevant for you in the future that is stored in the entity memory. So now comes the first part where we'll be discussing in more detail, which is conversation buffer memory. So conversation buffer memory stores the entire information conversation without removing any key. So it will directly pass on the context whatever you have given and it keeps on iterating until your conversation is completed. So the advantage of this is very simple. It stores a complete history. It is easy to implement and the disadvantage of this is it is high token usage. So basically if you are having a very long conversation with the AI, so AI is taking all your information and storing it, so the token usage will be definitely very high. Then it's expensive for long chats. As I said, if you are having a very long chat, then it will be very difficult for AI to store everything context by context, and then it slows over time. So basically, if you are using it continuously, maybe for long period of time, after some time, the buffer will be maybe exhausted and it will queue the responses very slowly. So it's best for something like if you are building a small chatbot where the interactions will be very minimal, or like if a customer support bot you are building. So as we know, that customer support bot will mostly end within a span of 2-3 minutes. So for that kind of conversations, this conversation buffer memory is very helpful. So in a very simple language, this memory only stores the most recent conversation, where this stores every information whatever we give as input, and it's easy to implement. But as the conversation becomes longer, the prompts become larger. It increases the token limit as well as it slows down over the period of time. Now comes the next part, which is conversation buffer memory window, where we have we used to store everything based on the last k conversations are kept. So instead of storing everything, this memory stores only the most recent conversation. For example, if the window size is 5, only the last interactions are remembered. Older conversations are automatically removed. So advantage of this is smaller prompts, lower cost, faster execution, and perfect for customer support chatbots where only recent context matters. So, but the only disadvantage I feel like, for example, if you have given information at the very start and then you want to deal the entire conversation with it, then this will be difficult for you because definitely after some time it will start forgetting the old conversations. So that's where the disadvantage of conversation buffer window memory comes in. Now comes the next important thing, which is conversation summary memory. So basically, this instead of this storing a large context of text, it will summarize the entire context and keep the summary. So this will help to for much lower context, lower cost, and long conversations as well. So in a very simple language, instead of storing every message, the memory continuously creates a summary of conversation. For example, instead of you storing 50 messages, it will something like a large context of text will be shortened and then it will be passed to the AI. So this is how we are dealing with. So disadvantage of this it is like fine details might be lost because everything is compressed into the summary. Now we have a vector store memory where just like in a very simple example, I would suggest you like now imagine a chatbot that's been running for 6 months. So it may have thousands of conversations that have happened. So clearly we cannot send all of them to the model. So instead of you storing conversations inside a memory kind of which can be a blob memory, you can store something like this into a vector database. So whenever the user asks, the semantic search retrieves the most relevant fast conversations, and based on that, it will give you the answer. So this is something exactly which in future we'll be discussing, which is something about RAG, retrieval augmented generation. So in that we will be understanding how we can store all the conversation in a database and then how we can fetch it from the database. So this is something which we'll be learning in the future videos. And this is ideally used for enterprise scale AI applications. So you can see here the workflow, like conversation will start, it will be created into embeddings. The embeddings will be stored into vector database. And then with the help of similarity search, we will be retrieving the relevant information, relevant memory, and then the relevant memory will be passed to the LLM and LLM will give you the response. And now comes the next important part, which is entity memory. So this is basically used when you don't have to store all the context or all the summary. But here you want to store something which information is important for me. So for example, rather than you giving everything, it should not store everything. So it will only take the relevant information like your name, company, entities, whatever exists, city, role, and these details will be stored in the memory. And then whenever you ask any question, the query, it will just take this memory as input and it will give you the output. So if you want something a personalized conversation based on your insights or your input, then entity memory works the best. So these were some of the important techniques I have discussed here. And if you ask like which memory should you use, so let's simplify it in a very simple language. If you are building a small chatbot, a conversation buffer memory is enough. If your recent message matters, then you should use a conversation buffer window memory. If conversations are too long, then conversation summary memory is a better option. Then if you want summaries and recent messages, then you should choose a conversation buffer summary memory. And if the token limits are a concern, then conversation token buffer memory is an ideal one. Then like this lot of different we have models. We will have the functions, memory functions. You can just explore it, and if you want something to build for an AI enterprise application, which should store a massive amount of conversation history, then vector store retrieval memory is the best. And if your application resolves around the user details, then entity memory works best. So remember that there is no any universally best memory. The best choice always depends on the use case or the application which is built on. So if you ask like some of the best real world use case for memory is AI tutors, healthcare assistants, travel booking agents, banking chatbots, HR assistant, interview preparation bots. So basically any application that requires continuous conversation depends on memory. It requires a memory. So now I think so we are good to go with the theoretical side. Now we will take some demo where I will be creating a entire like kind of a chatbot using the memory. So now let's start with the most basic one, which is a conversation buffer memory. So here also we will start the same way how we used to do for the others. We will take the basic prompt templates. So let's take this, which we need in almost every video, every model that we build. So we need a .env, for sure we need chat models, for sure we need LangChain, but we are using here LangChain.chain, so I will read this from LangChain. LangChain.chains. I am going to import conversation chain, which we have auto recommended. Okay. So here, now next thing which we want to import is from LangChain dot memory import conversation buffer memory. Okay. Let me write second from LangChain 4. Sorry, LangChain chain. Okay. So now then we are loading a .env file, the .env which we have created here. We have a requirements.txt. You can install the requirements.txt. I will just show you. These are the requirements. So these requirements you have to install. And then comes the part where we'll be initializing the LLM. So I have initialized using each chat model. My model is GPT 4.1 mini. Then I'm using the model provider for the OpenAI. So now comes the next part, which is the important where we are following the memory. We are following here conversation buffer memory. And now we are following conversation as creating a variable where it will be following the conversation chain, and I'm assigning LLM as and LLM and memory to memory. Okay, so we are good to go till here. Now I will be putting a condition like while it's true, query should take an input, and my user will be you, and the response should be conversation dot invoke input and query. Okay, and now comes the last part, will be printing. Printing will be, let's assign an AI. Okay, so we are done here, and now I will be running this code. Python. So if you are new to this file, you have to first install the pip install minus r requirements.txt to install the entire packages, and then you have to run the file. Okay, so now let's start. Hi, my keywords are. Okay, so it told me hello Aryan, it's great to meet you. How can I assist you today? So let me tell in that I am an AI engineer. Okay, so I am learning LangChain. Now I will ask what is my name. Okay, so it remembers my name. So based on my given input, which I was given 4 chats before, it remembered the entire conversation, and this is how it gave me the final response. So now we are going to take another sample where we will understand on window. Let's understand what window. So window, I will just tell how to do. It's very simple. You can just experiment from yourself. Like I just need to do the conversation, and if I use this conversation buffer window memory, then it will be using window function. And then here, if you assign a k value as 2, then it will remember only the previous last 2 instances of the chat. So you can use this to create a window buffer memory. You can create this, and then if you want to use a summary, so you can use this conversation summary memory, and then this we have to use here as well, and this will basically store your summary of all the previous instances. So this is what all about. You can experiment it. It's just single line of code you have to change. You can try all the different techniques available. For vector one, we need to. I will explain you when I am teaching RAG. So for now, I think so this much is enough for you guys to understand. So if you like this video, please subscribe the channel. Please like the channel, and I will be coming with more amazing videos like this. Thank you so much.